All right, so last class we went through inequalities in one triangle. We started comparing angles and sides all within one triangle. So for today, we're going to do it in two triangles. We have inequalities of two triangles, 5.6 here, inequalities in two triangles. And what helps us do this is what's called the Hinge Theorem. Now the hinge, those who don't know, guys, if you think about it, it's where doors. It's the pivot point of doors, where doors open and close. That little hinge thing that keeps the doors from falling off, those are hinges. They open up, close. So the Hinge Theorem, as it says here, is if two sides of one triangle are congruent to two sides of another triangle, so two sides of each triangle are congruent, and the included angle of one is larger than the included angle of the other, then the third side of the first triangle is longer than the third side of the second triangle. So what it's saying, basically, two triangles both have two congruent sides. So we're almost like side angle side or side side side, except the third sides are different. And it says that given that if one angle of one is bigger than the angle of another, the included angle, so side angle side, we're thinking of this, that angle in between is one is bigger than the other, then the side opposite the bigger angle is longer than the side opposite the smaller angle. Makes very much sense if you think about it in the one triangle. The bigger the side, the bigger the angle, the bigger the angle, the bigger the side. Same thing, except now we're dealing in two triangles. And so I got an example here, triangle ABC and DEF. We see that AB is congruent to DE, AC is congruent to DF, but angle A is greater than angle D, so therefore the side BC, opposite of A, is greater than the side of angle D, which is EF. So again, bigger the side, bigger angle. It also makes sense if you think about it, guys. A door and a door frame, those are two sides of a triangle. The wider the door is open, the bigger the distance between the door and the door frame. If you think of it that way, it makes it very easy to visualize. And of course, just like last class, we had the converses. So we also have the converse in the Hinge Theorem. And it states, two sides of one triangle congruent to two sides of another triangle. And the third side of one triangle is longer than the third side of the second triangle, then the included angle is larger than the included angle of the second one. So we see again, I'd use ABC and DEF again. AB congruent to DE, AC congruent to DF, and we see that side BC is longer or bigger than side EF, so therefore the angle opposite of BC, which is A, is greater than the angle opposite of EF, which is D. So again, bigger side, bigger angle. Smaller side, smaller angle. And then I got a nice little example here. So we have this figure, and we said, how does angle PST compare to angle SPR? And so if we look at it, we have two triangles. We know PR is congruent to TS. We also, by reflexive property, can see that PS is congruent to itself. So look, we have two angles, or two sides congruent to two sides of another triangle. Two triangles with two sides congruent. And then we look at the sides opposite. So we have PT and RS. And we see that PT is bigger than RS. So based on the converse of the Hinge Theorem, we can then say that the angle opposite PT, which would be S, or PST, is greater than the angle opposite of RS, which is SPR. So we can then say that angle PST is larger than or greater than angle SPR. And that pretty much is how the Hinge Theorem is applied.